Hello everyone, let's look at LeetCode problem number 200, number of islands, which is also today's problem of the day. Let me quickly explain you the question. Here we are given a 2D matrix of characters containing 1 and zeros. Here 1 represent water, land and 0 represent water. We are also given that the matrix is surrounded by water. The adjacent ones contribute to the same land. The adjacency are defined either horizontally or vertically. So let me quickly show you the matrix. How does it look like? You can see that the adjacent ones are shown here by yellow and they are surrounded by water, blue. So as you can see in the matrix here, this is one part of a land, this is another part and this is another part. Note that the ones which are not adjacent if they are diagonally. So the answer to this question will be 3 as there are 3 islands. It is very similar to yesterday's problem of the day, which was relatively easy. Let's move on to the approach of this problem. So we can solve this problem even by DFS or BFS. I am choosing here DFS. So let's just trace our approach. What we will do is traverse the matrix, and as we find one, we will call DFS, and then DFS will count all the adjacent land to the one and count it as one island. And then when there is no one adjacent left, it will return, and then we will continue traversing till we find the next one. One key point to note here is that as we go to a 1 and we call DFS over it, we should mark it as visited. For marking it as visited, you may either use a 2D matrix visited, or you can, like the previous question, turn it to a different value that we are not using, such as 2. But to keep things simple, as in this question we don't have to count the number of edges like yesterday, we just have to count the adjacent islands and consider it as 1. We can flip this to 0, which will make our code concise. So while traversing, we'll find here 1. So we will call DFS function over it. As we call DFS function here, it will be flipped to 0. Then it will call to its neighbors. This is 1 here, so this will also be flipped to 0. Its neighbor here, it's 0, it will return, then it will go bottom. Here this is 1, so it will be flipped to 0 and explore its neighbor. Here it's 0, so there will be nothing. It will return, then it will go there. Here is 0, it will return, then it will go right of it and turn it to call DFS over it, so it will be turned to 0 and it will check over it. Now you may understand why we flipped it to 0, otherwise it will call the DFS function again over this one if we won't have flipped it to 0. Now it will check all of its neighbors, all of them are 0, so it will return here, and then it will return from here and it will return from here back. Now as we have completed the DFS, we will return 1 from here. We won't return anything from the DFS function, as we are finding 1, we flip all the adjacent of 1s to 0, so we will increment our counter to 1 as we find a 1 and then convert all the adjacent 1s to zeros. Then we'll again continue traversing the matrix from our number of island function. So then we will move here, it is 0, here it is 0, 0, 0, 0, 0, 0. So it will find the next one here. It will call DFS function over it. So now our counter was 0. By this it was turned to 1. Now it will be turned to 2 and DFS function would be called on this one. It will explore all of its neighbors. As you can see, all of them are 0. It will also flip it to 0. So nothing will happen and a counter will be 2. Again it will return the DFS function will return back to the num is land function, and then we'll again continue traversing the matrix. We'll find again one here. So DFS function will be called over here and counter will be increased. So it will turn to 0. Then it will explore all of its neighbors. It is already 0. Here it's 1. So it will call DFS function over here now, and this will be flipped to 0, and then it will check all of its neighbors. So as we are now out of the matrix, we have considered all the ones and flipped and ignored the adjacent land to it. So our counter is 3, which is the required answer to this problem. Now let's quickly see the pseudocode of this problem. There will be two functions. One will be int num is land. We are having the grid here. So in this function we are just traversing the matrix, and when we find 1 we will be calling the DFS function over it. So for I in row and inside it for j in column, we will call if grid of ij is equal to 1, we'll call DFS function over grid I and j. Here we also have to increment the counter here, so we will have to make a counter variable. So cnt is equals to 0. Here we will do cnt plus plus. So now this function is over. We will move on to the DFS function. Okay, so now let's look at the DFS function. As discussed, DFS function will be of void type. It will take argument of grid I and j. So first we'll writing the base case. So one of the base cases is our indices going out of bounds. So the conditions would be if I less than 0 or j less than 0, or I is greater than equal to the number of rows grid dot size, or we have j is greater than equal to number of columns, that is grid of 0 dot size. So if we go out of bound, we will just return from DFS. Also, if the current cell I, that is grid of ij, is equal to 0, we will do nothing and return from here. Now the main part of DFS function is here, so we are left with grid of I j equal to 1. After these conditions, we have only this condition, or you can also write it in a condition or else statement. So what we will do is first mark it as visited. For marking it as visited, as we decided, we will turn grid of ij to 0. So let me write a comment here, marking as visited, marking visited. Now we will call the DFS functions over all the neighbors of I and j. So calling DFS function on all the neighbors, so it will be DFS grid I minus 1 j, DFS grid I plus 1 j. This is nothing but the top neighbor, this is the bottom neighbor of ij. So then we will call the left DFS, so grid I and j minus 1, and finally for the right neighbor, grid I and j plus 1. So this is the left neighbor, this is the right neighbor. So thus we have completed our DFS function. So now if you have any suggestion or you have a better approach to this problem, write it in the comment section and give me any suggestions if you have for the future videos. Till then, bye bye.